Also got the supercapacitors in series, so I could put 12 volts across them. The only drawback is the capacitance won't add up, so I can put them in parallel, add the capacitance up, but I need a 5.5 volt supply to charge them. They're rated for 5.5, so I need 5.2 volts I think to charge them, which I don't currently have a 5.2 volt supply to charge them with, so let's try this method. So I can put them in series. I think their capacitance lessens on each capacitor in the circuit, so I'll see how much I'll charge like this, and if we run one of these. These are all potential drag race contestants. Little motors in there, good for drag racing, which I'm going to do next. So we'll see if we can run one of these with a charge in this and how long for. So I'll charge it up. So yeah, they'll take 15 volts easy. They're 5.5 volts each, so that's about 12 volts there. If you will see how much these capacitors are charged. I think they're a bit leaky actually. You can see here they've been leaking a bit. Bugger. Yeah, that's unfortunate. They've been leaking a bit. Past the use by date. What a bugger. I did some current tests. Sure enough, there's no current in those capacitors. They can't store current, which is a bit of a bugger. I would have been useful to charge an output or something with these. Even to boost me, I've got a wind up dynamo torch flashlight. Would have been good to add these in there to get me some more runtime out of it. Would have been ideal, but although they charge up alright, they're googled. Yeah, I think they're googled up. Anyway, it's a bit unfortunate. But I found some more drag race contestants. One's a vibrating one. Have to whack a disc on that. Let's do some more drag racing, eh? Let's see how fast these motors can go. Here's a high and low speed one. Off, low and high. Here's a diode to reduce the speed. This is a ZTR motor, the brand. There we are. Made in the People Republic of China. Let's get these things racing. Yeah, they're charging alright. Not getting warm or anything though. Yeah, they're not storing not storing much current at all though, unfortunately. Which is a bugger. Anyway, let's start racing. Racing. Alright, let's get the variac on. See if how accurately this works. Alright, but it tape out to balance itself. Very close, I think. Here we go. Well, here we go. There we are. Let's go see how fast we got. Is that it? That's not much. Oh, this thing was pants. Average. Zato 7900 RPM. Pants. Absolute pants. Anyway, let's disconnect. Unplug safety first. I had that on there. The reflective part. And this bloody tape let it down, I think. That was working alright at low speed. As soon as I split it up, this tape came off with a centrifugal force and slowed it down and threw it out of balance. So this is a bit of a letdown, but it does work. The reflective part there spinning around does actually work as a good reference to the tacho. Oh well, let's get another motor and try again. Got to get better than that, surely. Drag race the next motor. As to the brand, well, I don't know what brand these are. They're just generic Chinese motors. They feel kind of heavy duty though, so there's a flat washer on the back of that to stop any axial play, or any excess axial play, because it's designed to be pressed and loaded down axially. But they're just little face buffers, cosmetic things. They're not needed anymore, so let's see how well this one goes. This the best thing I can come up with as a way of measuring the RPM. The other blue big disc I've got doesn't fit these motor shafts, unfortunately. So it's going to have to be this way. 400 watt ballast. Alright. bit better. Here we go. Smoky. It's dead. Alright, let's get a memory measurement. First, we'll unplug safety first. Oh, is that all? 12,582. Man, these motors aren't designed for it. Average. I was expecting like 70,000 RPM out of these little things. These things are pants. 12,500 RPM. These motors just don't have it. I reckon it's the way I've loaded them up though. That's the best I can come up with to measure the RPM. There's bogged them down here. I sort of had them something on here, straight in the shaft. Would have been a better way to do it, but this is the most reliable method to count the RPM. Either way, I've got a result. Thanks for watching.